Welcome from Virginia. I'm Barbara Dill, and this part of my presentation is going to be a deep dive into a conceptual model that explains a systematic way to understand multi-axis spindles. I've been fascinated with spindles ever since I have been turning since 1990. In the 90s, I didn't know what to do next, so I randomly changed the axis and made hundreds of spindles, but became frustrated because I wasn't aware of what I should do next. So fast forward to 2006, and I really decided I would try to figure out what these spindles had in common, and I actually did figure out some stuff that's been very useful. So I hope you enjoy this presentation. One thing I wanted to say is I could show you just how to turn one thing that I do, and then you would know how to do one thing, but you wouldn't still know how to do something different or do more than that project. So that's why, to me, it's really important to teach these concepts. There are links to papers I've written on my website, which is www.barbadill.com. And my book can be found on Amazon. It was published in 2018. It has a lot of information in it. There is a lot of information to this, so it takes a lot of turning to not only understand how all of these concepts work together, but also to gain the skill necessary to really turn multi-axis forms without having to do a lot of sanding, which I think most of us don't like. There are many ways to do many things. I have my own numbering system. I'll show you the tools I like. That doesn't mean they're the right way to do everything. It's what works for me. So whatever tools work for you, whatever systematic way you develop is perfect for you. My challenge has always been, when I teach, to start small and then grow these ideas in a way that's understandable to you. And I challenge you to start small and start with smaller ideas. And as you understand how the variables work and how the quadrants and the families work and the axes work, you can grow those ideas to your own, develop your own forms that you've probably never seen before. I really think that there are a lot of forms that have yet to be found and discovered. So enjoy this presentation. Thank you. Now we're going to get into the basics of this map that guides you through a systematic way to understand multi-axis spindle turning. I find now that it's quite simple, but back then it wasn't simple at all. But what I discovered are there are only two ways that the new axis can be moved relative to that center axis. It's either parallel to that axis or not parallel, which we call twisted. And there are only two results or outcomes that happen on each axis that you turn. You either cut into the air wood and create an arc-type spindle, or you go all the way to the new solid wood and create a circular element, and that's called circular type. What I'm going to do is unpack these ideas slowly. So here's all you need to know about axis placement. Essentially, what I'm talking about are the drawings in the upper left-hand corner. There are only two basic ways the axis can be moved relative to the center axis. In the drawing on top, they're twisted, or they cross the center axis or any line parallel to that center axis at some point. In the drawing underneath it that I'm pointing to, these green and blue axes are parallel to that center axis. And that can happen with both types of turnings. And now let's talk about the results. They're either arc type, which is the drawing on the left, that has three axes separated by 120 degrees and a very long cove is turned on each axis. And as the axes change, these coves intersect, creating lines that intersect. And they're really arcs that are intersecting if you cut it in half. So that's called arc type, and the one on the right is circular type. In this spindle, I've cut through all of that air wood, unlike the spindle on the left, that would have been a cove up here. Cut through all the air wood, got to the solid wood, and created a profile, which in this case is a bead. switch the axis, cut through that air wood, created a bead, and on and on. So there are two types, arc type and circular type. And there are two types of each. Arc type can either have parallel axes, like the one on the left, or twisted axes, like the image on the right. On the one on the left, these parallel axes are in the same plane as the center axis, 180 degrees apart from each other. So if I pull that axis down parallel to the center axis, oops, I didn't mean to do that. If I pull that axis down, then I'm cutting into the air wood here and creating a bead and a cove and a bead. And then when I switch the axis over here and then put it between those 2 points, then I can create this other axis, which is a cove on top of the bead, a bead on top of the cove, and so on. And this one is twisted right here. It's 3 axes separated by 120 degrees, twisted at 120 degrees with long coves. What happens in arc type is this. You have a piece of wood on the lathe. Now this cylinder was turned on an axis that's about where I'm pointing in the center of the cylinder. Now I've put it on a parallel axis closer to the outside of the spindle. And as it rotates, I have cut a cove in the air wood, what I call the air wood. You only hit it once as it's coming around. So that's how arc types happen. And with circular types, when you cut through the air wood and grab the solid wood and then create a profile, you can have parallel or twisted axes. The one on the left is twisted axes. There's one axis on the top and 3 or 4 on the bottom. Every time the axis was switched, you'd go to the new cylinder and in this case just create a cylinder. And on this other circular type with parallel axes, I could have done that same thing here, that same idea, but this one is a little different. They're parallel axes, and every time the axis was switched, I turned a bead or an element. And this is the way that looks on that same image that I showed you. The cylinder was turned. To create a circular type, you cut all the way down into the solid wood. Now, I could have made that cylinder a lot longer and created some profiles, but this, in essence, is what happens when you're making a circular type spindle. So now we have elements, 4 elements, axis placement, parallel, and twisted, and outcomes, which are arc type and circular type. And now we can create this table that has in quadrants. Each quadrant represents a family of spindles that have something in common. They have the type of axis and the type of outcome in common. So quadrant 1 has arc type and parallel axes. Quadrant 2 is a family that has arc type and twisted axes. Quadrant 3 is the family that has circular type and parallel axes. And quadrant 4 is the family that has circular type and twisted axes. So there are the 2 quadrants, the 2 families that have parallel axes. Here are the 2 families that have twisted axes. Here are the 2 families that are arc type, both parallel and twisted. And here are the 2 families that are circular type. Now, when I started figuring this out, I started turning smaller pieces of wood to experiment with what would happen with parallel axes and twisted and arc types and circular types. So I used Velcro, and I put all these little samples here just so I could continue to understand what I was learning. Now, this is your handout that you can get off my website. It has all the information that's critical about the basics of how all this works, the map of multi-axis spindle turning. Next, we're going to get into the variables. But first, let me tell you that what I've been talking about is spindles that have the entire idea on one spindle. You can certainly combine ideas on a spindle. For instance, this walnut spindle in the middle, it has 3 types of turnings on it. The top part, they have axes that are 3 axes that are separated by 120 degrees. The top part are 3 arcs that are separated in parallel axes, separated by 120 degrees, and they're parallel axes. The bottom are 120 degree separations and twisted at 120 degrees. So they're twisted, and then the sphere in the middle is on one of the off axes. So you can certainly start playing with combining the ideas to make really amazing and fun forms. Well, the essence of this model of understanding multi-axis spindles is that when you have a piece of wood that's spindle wood on the lathe, the new axis is either going to be parallel to that center axis or not parallel. So parallel means it's equidistant from the center axis and in the same direction on each end. So I'm going to scribe a line on this spindle on each end in the same plane and inscribe it through the center axis. I eyeballed it, it's close enough. And then I'll mark, about 3/8 from the outside on each end. And so the new axis, theoretically, without doing a ton of measuring, will be parallel to the center axis. And let me see what that looks like now. Let's put this point in there. And then this point here. I'm going to turn the speed down and show you what that looks like. I don't know if you can see it with the light on or off better. But there's wood flying around that if I put a piece of chalk to it, I only hit the wood once. And then there's solid wood. That's the solid wood between the headstock and the tailstock. So there's air wood or ghost wood, which is what you cut into on a parallel or a twisted axis, because I placed the axis closer to the outside in this example just to show the difference between the air wood and the solid wood. So that's one type of axis you can have when you change the axis from the center axis. It's parallel to the center axis. The only other type of axis you can have is called twisted axes. And a twisted axis is not parallel. I'm going to leave the headstock axis on one end and put this one off center so that it's not parallel to that center axis. And now you still have air wood and ghost wood, and the air wood is the wood that you only hit once with a tool. I'm going to mark that with purple now. And then you can cut through that air wood and get to the solid wood. So only two types of axes, parallel and twisted. Okay, we're going to talk a little bit about where do you place the axis, given you have to make a decision before you start a multi-axis piece. So let's talk about axis placement. We already know that axes can either be parallel relative to the center axis or not parallel or twisted relative to that center axis. But then where do you put them? Do you put the new axis closer to the center or the outside of the spindle? And how do you make those types of decisions? Let's talk about circular outcomes. If you place a new axis closer to the outside of the spindle, then the size of the new cylinder you're going to make is going to be defined by the distance between that point and the outside of the cylinder. So let's say the new axis is really close to the outside of the cylinder, and we're going to cut through all that air wood and create a cylinder here. So this cylinder is very small, and if you have 3 axes, I'm using 3 axes as an example, but if you have 3 axes and I do the same thing here and here, I'm going to have a hard time with each segment of this spindle connecting those segments. If I put the new axis in the center, about equidistant from the outside and the inside of the center of the spindle, then now the radius is the distance between that new axis point and the outside. Now, when I go cut through all of that air wood and create a new cylinder, the cylinder will be larger. And if I do that on all 3 sides, the cylinder will intersect and I won't have such a fragile piece that I'm working with. Now, you can imagine that this is either the end of a spindle or any cross section of the spindle. So on parallel axes, that would be the same distance and the same size. On twisted axis, if I take a cross section, like say here, then the size up here of that solid wood will be this size. The size here of the solid wood would be there. The size here of the solid wood would be that, and on and on. So on a twisted axis, the distance from the outside of the spindle will determine the size of the cylinder you have on which you can create a profile. So there you go with circular outcomes. Well, what about what about archetypes? Now with archetype, the simple explanation is this. When I put a new axis closer to the center axis, and let me put it here, then I will start cutting into this wood over here, and I will create an arc. And if I do that on all 3 axes, then these arcs will intersect depending on the depth of my cut, and I will have a 3-sided object like a goblet or a cup or a candle holder. So the radius is the distance between the point of the new axis and my arc that I'm cutting. This radius is shorter than if I placed the new axes closer to the outside of the spindle and I cut an arc. Now the radius is longer and the arc that I cut is going to be flatter. So right there, there's a design element about the shape of the arc and if it's more curved or more flat. So now I'm going to show what an arc type or a circular type of spindle is. So here we have a spindle on one axis. I'm going to draw a circle on each end, and it's probably halfway between the center and the outside. And that way, if I want parallel axes, they're going to be in the same distance from the center. Or if I want to do twisted, then I can make sense out of what I'm doing. They don't have to be the same distance from the center axis or the outside. But a lot of my experiments have them be that way so I can learn about what's going to happen. So now that I have that scribed on the center, now I will take this off and let's mark 3 axes. So I can eyeball that, or I'm going to mark 3 axes on the end of this, or I can use my little plastic yogurt container tops that I have made jigs out of so that I don't have to do a lot of measuring. I can find the center, I can mark where the 3 axes are. And now I can scribe a line to that center axis from those 3 marks. And this is a fairly accurate way to find axes that are separated by 120 degrees. Now I'm going to eyeball that to the other end. I'll just draw those marks up. If I was doing something that really required these measurements be exact, I wouldn't do it this way. I would use another way to do it, use a jig or something. But now I have the 3 axes. Now I'm going to number the other thing I always forget to do, and I'm going to do that now. I'm going to put it back on the lathe just so you'll see this. And I remember to do the circles on the inside, but I want to give myself about a little more than a ½ inch on each end, because this spindle is not only going to be an experiment, it's going to be the way I take notes about what I just did. So this is the headstock end, because I know that because I have 4 prongs there. So you always need to keep the headstock at the headstock and the tailstock at the tailstock, because if you don't, it's backwards. It's backwards. So on the headstock end, I'm going to number 1, 2, and 3. And I'm going to number them on the outside of the spindle because it's easier to see. And you will find out that it's very easy to get a brain cramp when you're doing this kind of work. You forget which is the headstock and the tailstock. You forget the numbering system. There are a lot of ways to mess up. So you want to try to make it as clear as possible in what you're doing, and it's still possible to mess up. Now this will be arc type. I'm going to show you what the difference between arc type and circular type is. And what I will do is press in, first I'll do parallel axes. So parallel will be 1 to 1. So I'll press in 1 to 1. Ooh, it slid. I press that in ahead of time because this joint between the headstock and the wood is really important, and it takes a lot of pressure to make sure those prongs bite into the wood. If you make these spindles thin, then you can't put that pressure between the headstock and the tailstock. So I'm going to do this on all 3 axes. That was 1 to 1. Now it'll be 2 to 2. And I freeze the shaft here so I can wiggle it to make sure those points bite in to the wood. 2 to 2 and 3 to 3. And then I have my 3 parallel axes set up. The 4-prong drive center that I use at the headstock, I bought in the early 2000s from Woodcraft, and Craft Supplies had them as well. They don't import these anymore. They import 3/8 and 5/8, but to me, a ½ inch. It has a long point right here and 4 prongs that are filed back so this can really bite into the wood. I don't know if you can see it. So I like these a lot for the kind of work that I do. Now I'm going to turn the speed down, adjust the tool rest, make sure that the wood is not going to hit it, and turn the lathe on. And now what I'm going to do is just cut 1 long cove between, see, it's off balance, so I have to turn the speed down, or I could turn it up and get rid of that, get into a harmonic. To create a cove on this, I'm cutting into the air wood, but you do it exactly the same way you create a cove on one axis. I'm going to start in the middle and work back and forth and go downhill. The tool I'm using is a ½ inch bowl gouge, sharpened like a spindle roughing gouge. I just feel like I have more control over this. It's not quite as large on the top as a spindle roughing gouge. So I'm just going to go backwards and forwards, making a cove. Increasing the speed is sometimes very useful, but vibration is a big issue that you have to contend with. This is a symmetrical cove. And I try to make a finishing cut as smoothly as I can because sanding these is not a lot of fun. I'll turn the speed up to make a finishing cut. And I've cut the cove into the air wood. I haven't cut deeply enough to hit the solid wood. And if you notice, the solid wood is only about a half of an inch in diameter. So now this is a symmetrical cove. Now what I'll do is do that on all three sides. And then what you get is a spindle that looks like this. These coves on all of the axes, the three axes, intersect, and that line is the line of intersection, and that's why they're called arcs type. The arcs intersect, making those lines that go up and down the spindle. So that's parallel arc type with three axes. You can do that on twisted axes, but I want to now go to the other type, which is circular outcome. So here's a spindle I'm prepping to do a circular type spindle on. I've already scribed the line on the inside to find the distance from the center of the spindle to the new axis, and lines on the outside so that I can mark the numbers of the axes that I'm going to use. But I want you to notice this, that when you're doing circular type outcome, the axes need to be at least closer to the center axis and not further than halfway between the outside of the spindle and the center axis. And the reason why is that when the axes are closer to the center, you have more solid wood and less air wood. When they're closer to the outside, you have more air wood and less solid wood. Oftentimes, if you're trying to make a circular outcome, what will happen is you'll run out of wood and they become very fragile and they break. So I've marked these sort of closer to the inside than the outside of the spindle. Now I'll go ahead and mark three axes on it like I did on the arc type. Numbering these spindles is really important. You have to have a systematic way or idea of how to number these spindles. What I've always done is match 1 to 1 on each end, 2 to 2, and 3 to 3. And if they're parallel, you go 1 to 1, 2 to 2, and 3 to 3. But if they're twisted, I will always go from the headstock end, the smallest number, 1, to the next highest number on the tailstock end, which is 2, and continue that. And of course, 3 in sequence goes to 1 on the tailstock end. That's just my systematic way to do it. You can use color coding, you can use letters. If you're going to do it twisting, you can number the tailstock or the direction you want the twist in 1 to 1 and twist it at 120 degrees or 90 or whatever. Okay, now I've numbered it. I've pressed in the axes 1 to 2, 2 to 3, and 3 to 1. And I might as well start at 3 to 1 because that's my last place that I press them in. So I usually build from the left side to the right side. It's just the way I visualize things. There's no right or wrong for that. My other favorite tool, in addition to this 1/2-inch bowl gouge that's sharpened flat on the top, is a 1/2-inch spindle gouge sharpened to a fingernail grind. So what I'm going to do is start, this is circular, so I'm going to define about 1/3 of this spindle, cut through the air wood, and find the solid wood. I usually try to turn as fast as I can because it decreases the amount of bounciness you get, the amount of times it's rotating and hits the tool. I don't know if you can see this, but there's more solid wood in the center than in the middle, and I'll explain that in a minute. Now I think I found the solid wood in this spindle, but I want you to notice a few things. One is the angle of the cut that I cut through the air wood in. It can be really steep or really wide. I like it to be a little wide just because it gives me more room to connect the axes when I move forward. But there are all those choices there, and I can make that smaller or larger. But once I've defined that cylinder, then I can, it's like a 1-axis spindle. You can do anything you want. You can turn a bead, a cove, or a V-cut, or whatever you want to do with that. So what I decided to do is just turn some V-cuts in there, and then I'm going to move on to the next axis. I could have turned a bead or a cove, so it's just playful now. So that knowing this information allows you to understand what you're doing next, but then you have a lot of play in figuring out what you want to do with each axis. Well, the first axis I did was 1 to 2. Now, I mean 3 to 1. Now I put it on 1 to 2. And when I turn this on, you'll get to see, well, one thing you'll get to see is there's not much wood between the headstock and the tailstock because of the cuts I made. But then you'll get to see the amount of solid wood and air wood. And how now that's blurry because that's not on an axis anymore. That's out of sync. So now I want to define the next third of this axis. I want to take nice light cuts. I'm going to take nice light cuts and I want to back into creating a nice intersection with these two axes. I use green wood because these cuts are hard to make and it's nice to have softer woods to cut with. This is holly because I can see what I'm doing and mark on it, but I think holly, once it's completed, you can see the shadows on it and it makes it really nice. But these are all personal preferences. Stop and start a lot just to see where I'm at with this cut. I'm backing into this V cut. I can continue cutting straight down that way. No, that's forming really nicely right there. Good, I like that. There's a little flat spot on this V cut, but otherwise it's all developing nicely. So I decided to do a bead here, and when I do this kind of work, I want to make sure that the ends are the same diameter and they're not quite here. But That's something I would focus on. And did I mention that it really helps to be able to reliably turn a cove, a bead, and a V-cut on one axis to do this work, because then you're cutting through air wood and you have to hit it reliably. Now I'll put it on the third axis. I'll do that now. So that was 1 to 2, and now I'll put it on 2 to 3. And make sure I get the points in the right place that have already been pressed in, so that there's a lot of stability there. I can't put a lot of pressure on this now because it's fragile. Now I hope you can see the way the tool is working. I just gently start cutting into the wood. Carefully cutting through that air wood until I get to the solid wood. I want to add that there's no right or wrong tool to use. It's whatever you've been using to turn spindles with. Some people use skews and I don't. But when you use a spindle gouge, I'm using the tip, and when I cut to the left, I'm using the left side of the tip, and to the right side of the tip. It's not an intuitive tool, I think, so it's really important to practice this on one axis. And so far I have not gotten to the solid wood yet, but I'm carefully working my way to it. This is holly that's been sitting on my deck, so it's rather dry, but it's still fairly easy to make these cuts. Let's take a look and see what's going on. Well, I've gotten all the way to the solid wood. There's a little bit of a flat spot right there, but essentially this is what it looks like to create a twisted circular type spindle, as opposed to a, let me get this off my head, our arc type. Totally different ways to do multi-axis work. These ideas can certainly be mixed and matched, but this creates 4 families now of spindles. Parallel, well, I'll go into that in a minute. So I've just shown you two types of axes, parallel and twisted, and two types of outcomes, arc type and circular type. A couple of things I want you to notice, and that is now, instead of taking notes on a piece of paper on my lathe about what I did on each spindle and not having a clue what I meant when I look at the notes, now I have all the notes on my spindles. So I know which is the headstock, which is the tailstock, and how I numbered the axes. So I know how both of these are made. That's one point. But my major point is this, that now we have two types of axes placement and two types of outcomes. It creates a grid of axis placements on the side going that way and outcomes going down like that. So well, one thing I decided that I would do in making a new series of videos is I wouldn't touch them up or correct things that I said that might not be that correct. I mean, sometimes I put words in that aren't what I meant. But I had to laugh at myself because I just went into my computer and I realized that when I was talking about this, I had it upside down. So I want to do that again. This is a handout. You can get it off of my website. But this encapsulates the 4 quadrants of families of spindles that have two things in common, the axis placement and the type, outcome type. So on this side and on the top row are parallel axes, on the bottom row are twisted axes, on this side are arc type, and on this side are circular type. So I call it quadrant 1 are all parallel arc axes and arc type. Quadrant 2, all twisted and arc type. Quadrant 3 over here are all circular and parallel. And quadrant 4 are all twisted and circular. So now it's the right side up and you can see it, but you can also download it from my website. Now, what does that do? Why is this important? It's important because instead of randomly changing the axis and not knowing what you're doing or what to do next, now you can say, wow, I just did that on 3 axes. What would happen if I did it on 2 or 4? And what would happen if I mixed circular and arc type? Or what would happen if I created shorter coves that were opposite from each other? Or created shorter coves on parallel axes that are alternating from each other. And then that's on 2 axes, 2 parallel axes. What would happen if I did that on 3 axes, parallel axes, and then 3 twisted axes? That's how much fun you can have once you start understanding how you can use this information. As I was reviewing this video, I realized that I was getting ahead of myself when I was talking about the importance of this information. The quadrants identify that each spindle or a part of a spindle has either what type of axis, either a parallel or twisted, and what kind of outcome, either arc type or circular type. There's a whole set of variables that are listed over here, and it's right side up, that talk about the variables that can be applied to each quadrant. So the profile, the size and the shape of the wood, the axes, and the millions of ways the new axes can be placed are all variables that apply to each type of spindle. And that will be coming up in the next video. So stay tuned.